In this example, we're actually going to be looking at histograms and uh, sampling and representing the statistics associated with the sample. Actually, I have a large enough sample that I'm not going to actually calculate the mean in front of you or anything, but I will show you how you might present it after collecting. I think calculating the mean and standard deviation of sample should be within your ability coming into the course. So we're looking in this case at 60 adult males who visited a particular medical clinic during a particular week. And you'll see this histogram in a moment. You're asked to comment on the sample, the population from which the sample is taken, the representativeness of the sample, obtain and interpret uh, sample statistics, and a suitable graphical presentation of this data set. So we'll even try a box plot and a histogram. So here's our histogram of the various males that came into a clinic in one particular week. This is not a particularly tall lot. You'll see only about 1, 2, 3 were above 6 feet. So again, not particularly tall. But from our statistics, we see this particular set of results. So the population might be interpreted as all adult males, or it might be interpreted as all adult males who visit this clinic. Depends on where the clinic is about whether or not you might regard it as particularly representative. The sample is the participating adult males who visited the clinic during the time of the sampling, and is it representative? Well, that depends on what your population is. Do we have any reason to think that it might not be representative? Well, I do. I think that's a particularly short set of men for the community in which I live. But if you are looking in some parts of, say, the United States, there are places where the population tends to be shorter, say Massachusetts or Chinatown in California. You might expect to find adult males who have short height, and they're in that case, if the population is interpreted as all adult males who visit the clinic, then it indeed might be representative. But I don't think it's particularly representative of the adult males that you'd run across if you regarded the population set of all adult males in the United States as the population for this sampling. Some of the height statistics that came from this would mean the mean and the standard deviation. We talked about how to calculate those, and I actually had a slide showing you how to get the sample variance, the S squared. Well, the standard deviation would be the square root of that. But notice that I had to include the units here in both the mean and the standard deviation. My median, the middle value, was 6.5, and a trimmed mean might be if I tossed out the top 10% and the bottom 10% and then took the mean of the remaining 80%. You'll see that might eliminate all outliers, but it really didn't substantially change the result. We might also get the upper quartile, the which would be the median of the upper half, and the lower quartile, the median of the lower half of the sample set. And if I wanted to report the interquartile range, again, I would also be taking the upper quartile minus the lower quartile. And notice all of these are reported with the units of inches in which this sampling was done. Lastly, in showing the height box plot for this case, you would simply have the large rectangular area extend from the lower quartile to the upper quartile with a vertical line at the median, and then I had the box plot extend in full range from the least value sampled to the largest one obtained, and I did all of this on some appropriate scale, which I selected in advance. And that's the box plot representing the same data set that you saw in the histogram. That's it for this example.